Good morning, my dear lovely students. Hope you're all fine today. In today's lesson, we are going to begin Unit 2, which is Algebra. The first lesson is Algebraic terms and algebraic expression. Unit 2 is so easy, it just needs concentration and more practice at home. So we are going to begin now with the first lesson, which is algebraic terms and algebraic expressions. Let's go now and begin our lesson and see what's an algebraic term and what's an algebraic expression. An algebraic term is formed from the product of two or more factors. Do you remember what was the meaning of the product and what is the meaning of a factor? Let's go together and remember. For example, when we used to say 2 times 3 is equal to 6. So, we used to say that 2 is called a factor, 3 is called another factor, and the answer of the multiplication was called a product. So simply, the two numbers that I multiply together are called factors. What about here, for example, if I say 2xy? 2xy means 2 times x times y. So, 2 here is a factor, x is another factor, and y is the third factor. Did you get it now? So, when I multiply any two numbers or more together, each one of them is called a factor, and the answer of this multiplication is called a product. Let's have a look now at more examples. If we said, for example, 3x squared, 3x squared means 3 times x squared. We have here two factors, 3 and x squared, right? What is the name of each one of them? That's what we are going to learn now. 3 is called a numerical factor or a coefficient, and we are going to use the word coefficient so many times during studying Unit 2. So, the numerical factor here or the coefficient is 3, and what about the x squared, which is the other factor that I have? X squared is a variable, right? And when I have a factor as variable or containing letters like x, y, a, b, and so on, I call this factor as an algebraic factor. And 3x squared altogether is called an algebraic term. Why? Because it consists of the product of two or more factors. I have here 3 as a numerical factor and x squared as an algebraic factor. What about, for example, if I say 5x? 5x means 5 times x, right? It contains two factors, 5 and x. 5, we said, that is called the coefficient or the numerical factor. And x is a variable, right? So when I have a factor as a variable or unknown, this is called an algebraic factor. And 5x together is called an algebraic term. Let's have another example. What about, for example, if I told you 4x squared y to the power of 4? I have here 4. This is my coefficient, right? Because it's the numerical factor. So 4 is the coefficient. And what about x squared? As we can see all that x squared is a variable, right? And when I have a factor as a variable, I call it an algebraic factor. So I have here x squared and the algebraic factor. And what about y to the power of 4? Y to the power of 4 is also a variable. And when I have a variable as a factor, so I call it as an algebraic factor. 4x squared y to the power of 4 all together is called an algebraic term. Let's go now and see how can I determine the degree of an algebraic term. The degree of an algebraic term is simply the sum of the indices of the algebraic factors in the algebraic term. So, the degree of the algebraic term is the sum of the indices, and indices here means powers, of the algebraic factor in the algebraic term. We know that the algebraic factors consist only of unknown, so the degree of the algebraic term is determined upon the sum of powers of the unknown. Let's have an example. What about, for example, if I told you 2x? What is the degree of 2x? We know that here the algebraic factor is x, right? Because it is the factor which contains unknown or variable. And I know that x here is to the power of 1, and that's why 1 is not written. So I can say that the term 2x is of the first degree, because this is the sum, or this is the power of the unknown. Let's have now another example. What about if I say, for example, 4xy? 4xy, this term consists of two algebraic factors, x and y. I know that x is to the power of 1, and that's why it's not written, and y also is to the power of 1. The sum of them together is 2, right? 1 plus 1 is equal to 2. So, this term is of the second degree. And let's go now and have more example. What, for example, if I told you 7, a to the power of 2, b to the power of 3. This term consists of two algebraic factors, right? A to the power of 2 and b to the power of 3. It's quite clear that a have the power of 2 and b have the power of 3. So to determine the degree of this term, I'm going to do 2 plus 3, which is the sum of the powers, and it's equal to 5. So this term is of the fifth degree. What about if I have, for example, negative 9? The algebraic term negative 9 consists only of numerical factor, which is negative 9. So now, what is the degree of this algebraic term? First of all, I would like you to know that when I have an algebraic term only having numerical factor, this term is called an absolute term. And an absolute term is always of 0 degree. Why? Simply because, for example, negative 9, it can be negative 9a to the power of 0, right? And still it's going to be equal to negative 9. So here, yes, I have an algebraic factor, but it's to the power of 0, and that's why it's not written, because anything to the power of 0 is equals to 1. So when I find again a term containing only numerical factor, it's called an absolute term, and any absolute term have a 0 degree. Let's go now and have more examples. The coefficient of the algebraic term negative 7 is, we said that the coefficient is the numerical factor, and here my numerical factor is negative 7. And how to determine the degree of the algebraic term negative 7? We said that when we have an algebraic term having only numerical factor, as I have here, negative 7, so this is called an absolute term. And an absolute term always have the degree of 0. So it's of the 0 degree. Let's have another example now. The coefficient of the algebraic term 2ab to the power of 2, or b squared. What is the coefficient of this term? We know that the coefficient is the numerical factor, and the numerical factor here is 2. And its degree is determined according to the sum of powers of the algebraic factors, or the unknowns. What are the unknowns here? I have a as an unknown, and I know that it's to the power of 1. And I have b here having the power of 2. So 1 plus 2, so the degree of this algebraic term is of the third degree. Let's go to another one. The coefficient of the algebraic term 3. Again, I have an algebraic term which has only a numerical factor, and this numerical factor is the coefficient, so the coefficient is 3. And we said that when we have an algebraic term containing only numerical factor, this means it's an absolute term. And an absolute term always have the degree of 0. So its degree is 0. What is the coefficient of the algebraic term 7a b cubed c? We know that the coefficient is the numerical factor, what is the numerical factor here in this term? It's obvious, it's 7. And what about the degree of this term? We know that the degree of any term is determined upon the adding or the sum of the powers of the unknowns or the algebraic factors. So here I have a, and I know that a is to the power of 1, b is to the power of 3, and c is to the power of 1. So 1 plus 3 plus 1, so this term is of the 5th degree. Let's go and have another example. The coefficient of the algebraic term negative 8x squared b is, again, the coefficient of any algebraic term is the numerical factor, and the numerical factor here is negative 8. What about the degree? I determine the degree according to the sum of powers of the algebraic factors. X is one algebraic factor and b is another algebraic factor. So x here is to the power of 2 and b is to the power of 1. So the degree is 2 plus 1, it's of the 3rd degree. The coefficient of the algebraic term xy squared is, do I have here a numerical factor? Yes, I have a numerical factor, it's 1, but 1 is not written. So I know now that the coefficient is equal to 1. And what about the degree? The degree is determined according to the sum of powers. I have here x to the power of 1 and y to the power of 2. So 1 plus 2, this term is of the 3rd degree. What about the coefficient of the algebraic term negative 2 to the power of 3? We all know that negative 2 to the power of 3 is equals to negative 8. So I have here an algebraic term only containing a numerical factor, which is the coefficient, and it's negative 8. And what about the degree? Do you think the degree here is of the 3rd degree? No, it's not of the 3rd degree, because we said that the sum of powers of the algebraic factors, and I don't have here any algebraic factors. The algebraic term here is negative 8, which is only a numerical factor. I don't have any algebraic factor, so again it's an absolute term, and the degree of any absolute term is 0. The degree of the absolute term in an algebraic expression is, we said that the degree of any absolute term is 0. Now, I would like you all to open your school book, page 32, and this is the answer of question number 1. You will write it in the table, and you will add the last two and write them also in the school book. Pause now, please, and write the answers, and don't forget to write the 2 examples also on the school book, and then let's go and complete our lesson. We know now what is the meaning of an algebraic term. But what is the meaning of an algebraic expression? Simply, algebraic expression consists of an algebraic term or more. Let's go and have an example. When I tell you 3x squared. 3x squared, it's an algebraic expression containing only one algebraic term. And when I have an algebraic expression consists only of one algebraic term, it's called a monomial. So the name given for an algebraic expression having only one algebraic term is monomial. What about, for example, if I have 5x plus 3? So here I have one algebraic term, which is 5x, and another algebraic term, which is 3. And there is a plus operation between them. So here I have an expression containing 2 algebraic terms. When I have an expression containing 2 algebraic terms, it's called a binomial. So, algebraic expression containing 2 algebraic terms is a binomial. Let's go now and see how many algebraic terms do I have here in this algebraic expressions. I have here 3 algebraic terms. 5x squared, 5x, and 3. So, when I have an algebraic expression containing 3 terms, this is called trinomial. Again, when I have an algebraic expression containing one algebraic term, it's monomial. An algebraic expression containing two algebraic terms, binomial. And an algebraic expression containing three algebraic terms, it's trinomial. And as you can see, between each algebraic term and another, there is an addition operation or a subtraction operation separating them from each other. Now the question is how to determine the degree of the algebraic expression. Simply, the degree of the algebraic expression is the degree of the highest term. Let's go and have examples to explain more. For examples, if I have 5x squared plus 5x plus 3. Here, this expression contains three terms. Let's go and determine the degree of each term. The degree here of the first term is second degree. I have only one algebraic factor, which is to the power of 2. So this term is of the second degree. Let's go now and see the second term, which is 5x. 5x, I have here one algebraic factor, which is x, and it's to the power of 1. So this term is of the first degree. And the last term, which is 3. And 3 is an absolute term, and we know that an absolute term is of 0 degree. To determine the degree of the whole algebraic expression, we go and see which term have the greatest degree. And here we have the first term is the greatest one, having the second degree. So the expression will have the second degree as well. So this algebraic expression is of the second degree. Let's go and have another example. 5x plus 3. Again, I have here two terms. The first term is of the first degree. And the second term is an absolute term, so it has a 0 degree. To determine the degree of the expression, it's the degree of the highest term, which is the first degree. 2x plus y plus zx. We have here three terms. The first term is of the first degree. The second term, its algebraic factor is y, and y is to the power of 1, so it's of the first degree as well. And in the third degree I have two algebraic factors, z, which have the power of 1, and x, which have the power of y. So, the degree of this algebraic term is of the second degree. To determine the degree of the algebraic expression as a whole, I will go and have the three terms, which one of them has the greatest degree. And I will find that the greatest degree is the second, so it's of the second degree. Let's have another example. If we say 4x to the power of 3 plus 2x to the power of 2 y to the power of 3 plus 10y squared. Here we have three terms. Let's go and see the degree of each term. In the first term, we have only one algebraic factor, and it have the power of 3, so the degree here is of the third degree. And for the second one, it's 2x squared y to the power of 3. We have here two algebraic factors. One of them is to the power of 2, and the other is to the power of 3. So here, this term is of the fifth degree. Going to the third term, I have only one algebraic factor, which is to the power of 2, so here it's of the second degree. To find the degree of the whole algebraic expression, just go and see which term have the greatest degree. And the greatest degree is the fifth degree, so the whole expression is of the fifth degree. Let's go and have more examples in page 32 in your school book. We are going now to solve question number 2. We have a table. I am given the algebraic expression. He wants me to find the number of terms, the name of the expression, and the degree. So let's go and begin. Negative 3a to the power of 5b. Here, this expression only contains one term. So the number of terms here is 1. And we know that when I have the expression containing only one term, so it's a monomial. And what is the degree? Here I have only one term, So the degree of this term is 5 plus 1. So the degree is of the 6th degree. Let's go now for number 2. 3x squared plus y. Here I have this expression containing two terms. And when I have an expression containing two terms, then it's called a binomial. Now let's determine the degree of the expression. I know that the first expression have the degree of 2, because x here is to the power of 2. And the second term have a degree of 1. Which one of them is greater? It's the degree of the first term. So the degree here is going to take the degree of the first term, which is the second degree. Let's move now. 5x cubed minus 7x plus 3. How many terms do I have here? I have 3 terms. So the number of terms I have is 3. And when I have 3 terms, it's called trinomial. What is the degree of this expression? Simply, I go and determine the degree of each term and see which one of them is greater. So, the first term is of the 3rd degree. The second term is of the 1st degree, and the third term is an absolute term, so it's of the 0 degree. Which one of them is greater? Sure, it's the first term, which is of the 3rd degree. So the degree here of the expression will be of the 3rd degree. Let's go now to the second one. 2a squared b plus 3ab squared minus a squared b squared. I have here 3 terms forming this expression. And when I have 3 terms, it's called trinomial. What is the degree? The degree I determine according to the highest degree of the terms. So let's go and calculate the degree of each term. The first term is a to the power of 2, b to the power of 1. So the degree here is 2 plus 1, which is equal to 3. What about the second term? The second term here is 3a plus a to the power of 1, b to the power of 2. So again, 1 plus 2, the second term is of the 3rd degree. And what about the third term? The third term is a to the power of 2, b to the power of 2, so 2 plus 2, the second term is of the 4th degree. We said that the expression takes the highest degree for the term. And here, the highest term is of the 4th degree, so the expression is of the 4th degree. X squared y squared minus 3xy to the power of 4. I have here this expression containing 2 terms. And when I have an expression containing 2 terms, this is a binomial. A binomial, and having 2 terms, to determine the expression degree, I must go and see the degree of each term. The degree of the first term is of the 4th degree, 2 plus 2. And the degree of the second term is of the 5th degree, 1 plus 5. So the degree of the whole expression is of the 5th degree, the highest term. Let's go now to the last one. A squared b minus 3ab to the power of 3 plus 2a cubed b squared plus b to the power of 4. This expression contains four terms. And when I have 4 terms, this is called quadnomial. Again, what is the degree of this expression? It's determined upon which term of the 4 terms have the highest degree. So the first one is of the 3rd degree, which is 2 plus 1. The second term is the 4th degree. The third term is of the 5th degree. And the 4th term is of 4th degree. Which term had the highest degree? It is the 3rd term, which is of the 5th degree. So the whole expression is going to be of the 5th degree. Let's go now and solve more example in our binder, page 13. The question number 1, complete. The degree of the term 3x squared y is, and its coefficient is. We said that any term consists of different factors. The coefficient is the numerical factor. What is the numerical factor I have here? In 3x squared y, the numerical factor here is 3. So the coefficient is 3. And what about the degree? We said that the degree of a term, I have the sum of the powers. I have here x to the power of 2 and y is to the power of 1. So simply 2 plus 1, so it's of the third degree. Let's go for number 2. The coefficient of the algebraic term half x to the power of 3 y z to the power of 2. We know that the coefficient is the numerical factor, and here my numerical factor is half. So the coefficient is half. And its degree, the degree of any term, is according to the sum of powers of the algebraic factors. I have here 3 algebraic factors, x to the power of 3 plus y to the power of 1 plus z to the power of 2. So it's of the 6th degree. Let's go for number 3, the coefficient of the algebraic term x. I have only here in this term an algebraic factor, which is x. So what is the coefficient? We say that we don't have a numerical factor, then the coefficient is 1. And the degree, here I have x to the power of 1, so it's of the first degree. Let's go now for number 4. The degree of the absolute term. We said that the degree of any absolute term is simply 0. So the degree of any absolute term is 0. Number 5. The coefficient of the algebraic term negative 2 to the power of 3. We know that negative 2 to the power of 3 is equals to negative 8. So here my algebraic term contains only numerical factor, which is negative 8. So the coefficient is negative 8. And the degree of the algebraic term negative 8 is 0, simply because the algebraic term negative 8 is an absolute term and the degree of any absolute term is 0. Let's go now for number 6. 5x squared plus 3 is an algebraic expression of which degree? Let's go now and determine how many terms we have inside of the algebraic expression. We have 2 terms, 5x squared and 3. 5x squared is of the second degree, and 3, it's an absolute term, and any absolute term is of 0 degree. And the degree of the algebraic expression is determined according to the degree of the highest term. And here the degree of the highest term is of the second degree. So the expression is of the second degree. Let's go now for number 7. The number of terms of the algebraic expression. 5y squared minus 3xy plus 2x squared. I have here between each 2 terms a subtraction operation or an addition operation between them. So I know now that I have 3 terms. So this algebraic expression contains 3 terms. And the degree of the algebraic expression is according to the degree of the highest term. I know that the first term is 5y to the power of 2, so it's of the second degree. And 3xy also of the second degree, because x have the power of 1 and y have the power of 1. And 2x squared is also of the second degree. Since all the terms are of the second degree, then the degree of this expression is also of the second degree. And let's go now again to page 32 in our school book. Let's go to question 3. Arrange the terms of the algebraic expression 7ab plus 5a to the power of 5b to the power of 3 minus 3 a to the power of 2, b to the power of 5, according to the descending order of the indices of a. So the first thing I shall do when he gives me an algebraic expression and he wants me to rearrange it, the first thing to see, he wants me to rearrange it according to the powers of what? Here he wanted according to the indices of a. So go and underline the a in each term. And then see what is the power each a takes in each term. So here 7ab, a have the power of 1. 5a to the power of 5, b to the power of 3. So here the indices of a is 5. 3a squared, b to the power of 5. So the indices in this term for a is 2. And then let's see, he wants me to arrange it according to the descending order. Descending orders means from the greatest to the smallest. So I am going to begin with the term which have the highest indices for the a. I know that the term that have the highest indices for a is 5, a to the power of 5, b to the power of 3. So I'm going to begin with it. And then let's see what is the other term. One of the terms having a to the power of 1 and the other term is having a to the power of 2. Which one of them is greatest? It's for sure a to the power of 2. So it's 3, a to the power of 2, b to the power of 5. But keep in mind that 3, it have a negative sign before it, so I must take it with me. So it's going to be minus 3a squared, b to the power of 5. And the last term is 7ab. And since there is no operation here before the 7, so it's going to be plus 7ab. Let's go to question number b. Arrange the terms of the algebraic expression 5x plus x squared minus 7 plus x cubed according to the ascending order of the indices of x. So first, let's go and underline x in each term. The first term 5x, the power or the indices of x is 1. The second term x squared have the indices of 2. The third term 7 here has no x beside it. And I know that when I have an absolute term, there is an algebraic factor here, but it has the power of 0. And x to the power of 3, of course the indices here for x is 3. Now I'm going to arrange them according to the ascending order. And ascending orders means from the smallest to the greatest. So I know that the smallest one is minus 7. So minus 7 is my first in the expression. And then I'm going to have 5x. And after 5x, I have still x squared and x to the power of 3. Which one of them has the smallest indices? It's x to the power of 2. So plus x squared. And for the third one, it's plus x to the power of 3. And let's go now and see question number 4. Write the algebraic expression which represent the area of the shaded region, then state its degree. Let's remember that we said before, when he asked me about the area of the shaded region, this means I am going to make the area of the large figure minus the area of the smallest figure. The large figure here is a triangle, and we know that the area of the triangle is half times base times height. And the area of the circle, he already gave me and said that the area of the circle is pi r squared. So to find the area of the shaded region, it's equals to area of triangle minus area of circle, area of the big shape minus area of the small shape. Area of triangle is equals to half times base times height, minus area of circle, which is pi r squared. Now we have here an algebraic expression. Let's go now and see how many terms is there inside this algebraic expression. We have two terms, half bh and pi r squared. What is the degree of the first one? The degree of half times base times height is of the second degree. And the degree of pi r squared is also with the second degree, because all of us know that pi is a constant number which is approximately equal to 3.14 or 22/7. So pi is not a variable. The only variable I have in the second term is r to the power of 2. So this algebraic expression is of the second degree. And let's go now again to our binder, page 13. Question number 5. If the degree of the algebraic term 5x to the power of n y to the power of 2 is 5. So I know that the degree of this algebraic term is equals to 5. And I know that the degree of the algebraic term is determined by the sum of indices of the algebraic factors. So here I have n plus 2, which is the indices for x and the indices for y. Both of them should give me 5. So n is equal to 3. Number 2, if the degree of the algebraic term y to the power of 2m is the degree of the algebraic term 5x squared y to the power of 4. So first of all, I know that the two terms have the same degree. So let's now go and calculate the degree for the algebraic term 5x to the power of 2 y to the power of 4. It's 2 plus 4, so the degree is of the sixth degree. I know that both of them are equal, so 2m should also equal to 6th degree. 2m means 2 times m. So m is equal to 6 divided by 2, which is equal to 3. Let's go now for number 3. The algebraic expression x to the power of 4 plus 3x to the power of n plus 1 minus 2x to the power of 2 plus 5 is arranged according to the descending order, so they are arranged from the smallest to the biggest of the indices. So let's go and have a look now. I have the first one, x to the power of 4, and I have the third one, 2x to the power of 2. So sure, the indices between them is 3. This should be 3x to the power of 3. So n plus 1 should give me 3. So n is equals to 2. Let's go now and solve question number 2 in our binders, page 13. Number 2, arrange the following expression ascendingly, one time according to the indices of A, and descendingly second time according to the indices of B. So first of all, let's go and see what is the indices for A. I have here a to the power of 2, a to the power of 3, a here is to the power of 1, a to the power of 4, and what about 4? 4 here should be having a to the power of 0. So here a is to the power of 0. Let's go and see how we are going to arrange them ascendingly. We know that when we are arranging ascendingly, this meaning we want to make it from the smallest to the greatest. The term here which have the smallest power for a is negative 4. And then the next one is plus 3, b to the power of 3, a to the power of 1. And then I have plus 2a to the power of 2, b to the power of 2. And minus 5, b, a to the power of 3. And the last one is plus 6, a to the power of 4, b to the power of 4. Let's go now to see how can we arrange it according to the descending order to the indices of b. Here I have b having power 2, here b is having power 1, here b is having power 3, here b is having power 4, and I know that since negative 4 has no b beside it, so b here should be having the power of 0. Let's go now and start arranging it descendingly. Descending order means from the greatest to the smallest. So the greatest power here goes for b to the power of 4. So the first term I shall put is 6a to the power of 4, b to the power of 4. And then let's go for the second one. The second greatest power for b is 3, b to the power of 3, a to the power of 1. So it's plus 3, b to the power of 3, a, and after it I have b to the power of 2. And since there is no operation before 2a squared b squared, it's plus 2a to the power of 2, b to the power of 2. And the second one I'm going to have is minus 5b a to the power of 3, and the last one is negative 4. By now we have finished today's lesson prep 1. I would like to thank you all and have a nice day.